All right. Well, welcome to the NCDS June DataBytes webinar. We have a lot of exciting information to cover in a short hour today. So I will be brief. My name is Amanda Miller. I'm the Associate Director of the National Consortium for Data Science, a project of the Renaissance Computing Institute, or RENCI, at UNC Chapel Hill. And it's my pleasure to welcome you to DataBytes. Just a couple of quick housekeeping items before our formal introduction. We ask that you add your questions today to the Zoom Q&A feature at the bottom of the screen. We'll leave about 15 minutes at the end of the presentation for a live Q&A session with our presenter, Kamal. And without any further delay, I'm going to go ahead and pass the mic to my colleague at RENCI, Anirban Mandal, who will introduce today's speaker. Anirban?
Thanks, Amanda. Greetings, everyone, and welcome to DataBytes, a professional development and upskilling series from the NCDS, which is a project of the Renaissance Computing Institute at UNC Chapel Hill. My name is Anirban Mandal, and Amanda invited me to introduce today's webinar. I serve as the director for the Network Research and Infrastructure Group here at RENCI, where I work at the intersection of distributed systems, scientific computing, and large-scale cyber infrastructure. And much of what I do involves building and studying systems that make scientific research possible, including cloud computing, networks, data-driven scientific workflows, and experimental testbeds that researchers across the country depend on. I also serve as the Associate Director for CI Compass, which is an NSF Cyberinfrastructure Center of Excellence supporting NSF major and mid-scale facilities, which makes today's topic particularly close to home for me. It's my pleasure to welcome you to today's DataByte session presented by my colleague Komal Thareja. NCT has created DataBytes because we believe that staying current with emerging tools and practices should not require a conference trip or a full semester course. So this series develops focused practical learning on the topics that matter most to data science, AI, and the research computing community. And today's topic is one we have been eager to bring to this audience. As you know, AI coding assistants have arrived in force, but if you search for guidance on how to actually put them to work for your use cases, most of what you will find is written for industry software teams building commercial applications. While the research community has very different scientific needs, different constraints, and frankly, different stakes, right? Things like scientific workflows or NSF major facility code bases, research software, and data pipelines do not behave like startup applications. And the people who build and maintain them deserve guidance that reflects that reality. So that's what exactly is our session about. So our presenter, Komal Thareja, she is a distributed system software engineer at RENCI and one of my colleagues in the Network Research and Infrastructure Group. And more information on the Network Research Infrastructure Group at RENCI is available on the chat. Amanda, if you could put that in, that would be great. And Komal's work spans some of our most demanding research infrastructure projects, including Fabric, which is one of the nation's premier programmable network research platforms, uh, NSF Flynet, which supports scientific drone missions, and a DOE project called the Swarm Project, which is reimagining how scientific workflow management systems work in a distributed environment. Komal has published peer-reviewed research on many aspects of network monitoring, distributed workflows, and general network services for scientific computing. She works every day with exactly the kind of complex research code that today's webinar is about. The examples she'll share are not hypothetical. They are drawn from real infrastructure challenges on practical NSF projects. So Komal is going to walk through practical role-specific workflows for PIs, developers, and students, address what AI gets wrong in research contexts, She'll share prompt engineering techniques that genuinely work and cover security considerations that the research community can't afford to ignore. This is exactly the kind of programming NCDS exists to provide: practical, public, and grounded in the realities of research computing. We're very glad that you're all here. Komal, welcome, and the floor is yours.
Thank you, Anirban. Um, Thank you, Anirban, for the introduction. Welcome, everyone, and thanks for joining. I'm Komal from RENCI, and today I'm going to walk you through how I use AI in my day-to-day work, building research cyber infrastructure, and what has worked and what doesn't, and the concrete patterns I have landed on after using AI for about a year now. And the goal isn't to convince you that AI is magic. It's to show you what a real working loop looks like and give you something to try on a Monday morning. Quick context on who I am and what kind of work I do. Uh, I'm a software engineer, not a researcher. Like I build infrastructure that researchers use. So I work across three NSF DOE projects. Fabric is a nationwide programmable testbed. Pegasus AI is bringing AI to scientific workflow management, and Swarm is workflow applications on resilient meta systems. All of these will show up in the case studies, so that's why I wanted to list them out here. So why this matters for CI specifically? Our world has a unique shape. We are typically small teams um, serving long-lived systems which have heterogeneous stacks and users who themselves are domain experts. So the pressure is real. More ambitious science, more facilities to integrate, flat or shrinking headcount. And AI tooling doesn't solve that on its own, but it changes the per engineer leverage in a way that's genuinely meaningful for how we plan projects and what we can take on.
Hey, Kamal, it seems like we've lost
Right.
audio.
Human.
I think we might have lost audio. Would you mind? I'm so sorry, but backing up maybe to the top of this slide.
Okay.
Thank
Um,
you.
AI is a force multiplier, not a replacement. It doesn't replace judgment, design taste, or domain knowledge. Those are still on you. What it does is it removes the friction between an idea and a working code. The 10x claim is real but uneven. For some tasks, it is very transformative. For example, if you were to build a prototype, you can have a working prototype in an hour. But for some of other tasks, it doesn't really do well. The skill and the thing I want you to take away from this webinar is learning when to lean on it and when to ignore what AI does. This slide talks about the tool set I use daily. Like I've been using Codex and Claude both in their desktop app version as well as the CLI version, which is the command line version. I also use them both with integrated development environments like VS Code, PyCharm. So this is the loop I run dozens of times a day. It basically involves 5 steps. Uh, Before I do anything, I write what I want in plain English and include constraints and non-goals. I interact with the AI agent about the goal I'm looking to achieve, and then plan. Have the agent basically propose a plan and argue with it before I ask it to write any code. This argument is necessary and is often ignored, but This gives you a chance to argue about different approaches you're taking, your design decisions, because when an agent is running in plan mode, it would prompt you with different kind of approaches you can use to implement your idea, and gives you design deci- make gives you questions wherein you can take design decisions for the approach you want for your solution. Once you have a specific plan which you're happy with, that is the point you let AI write the code in small reviewable commits. In addition to, before we go ahead and implement something, I also wanted to highlight is that when you're planning, make testing part of your plan. It should not be an afterthought. Before you ask AI to write code, you should also have a set of instructions in your spec development. Uh, on ways how would AI test what you are trying to achieve. So basically focus more on test-driven development. That way, it's easy for you to validate the results of the code generated by AI. And after it has implemented the code for you, uh, review it. Don't ask it to implement in bulk. Implement it in phases so that after every phase you have a chance to review what it generated. And since we're using a lot of AI assistants and the amount of code it generates, it could be huge. Practically speaking, reviewing that much code is not feasible. So having test-driven development helps, because in that way you can validate whatever was generated in phase one or phase X can be validated by the tests you came up with in your planning phase. Okay, moving on from how I work with AI in general into the first concrete case study. What Fabric is, this is like it's a Fabric testbed case study. What is Fabric? Fabric is a NSF funded programmable nationwide research testbed. And this map shows the footprint for Fabric. The blue dots you see represent different locations where Fabric has been deployed. We call them sites. Each site can be thought of as its own cloud, wherein you have wherein a user could request compute with accelerators, not only network accelerators but also compute accelerators, and connect those compute resources over the wide area network. So if you see the orange line on this map, it is a 1.4 terabit link. And then the network connections depicted by blue lines on this map are 100 gigabyte links. So Fabric gives you a platform wherein you can run your experiments on a real network um, at internet scale. In addition, not only we have like close to 30 sites within United States, and not only within United States, we have presence in Europe. We also have a site in Asia, in Tokyo, and within no, Fabric, when you're running an experiment in Fabric, your resources are not only limited to Fabric resources, you can also connect them to external facilities like, for example, if you were to use a public cloud, you could use AWS, Google Cloud, Azure, or other test beds, for example, Chameleon Cloud, Cloud Lab, or if you wanted to connect your own university campus resources, we enable that as well. You just have to reach out to us and we can work with you to connect those resources with Fabric. And we use Internet 2's Peer Connect to do that. So before I talk about what we did with AI, there are different ways to using Fabric. You could use our portal, which has a bare minimum capability for you to request resources on Fabric and run your experiments. And we also had a Jupyter interface wherein someone would write Python-based code in order to build an experiment on Fabric. So there is a huge chunk of code they would have to write in order to first acquire the resources, and only then they would go ahead and focus on the experiment part of it. So in order for you to use Fabric, you would have to learn our Python SDK, and that is a big hurdle and as a starting point. So we realized that, and that's why we thought of like using AI. How could AI reduce that learning curve for people to use Fabric? So they don't have to learn our Python SDK. They can just come in and start requesting resources on Fabric and focus more on the science bit rather than focusing on learning how Fabric works. So, in order to achieve that goal, we built a bunch of artifacts which are listed here. One of them being Loom AI, which is a browser-based graphical interface with an agentic assistant baked in. Weaves are packaged reproducible experiments. And then we also build Fabric skills, which can be plugged in with Claude or other AI assistants that let you build experiments on Fabric in a natural language. So all three came from the same observation, like should that users shouldn't have to learn our Python SDK. I will show a little bit more once we go into subsequent slides how we did that and what Loom AI is. So walking through the path from idea to a running slice. So Fabric has this concept of slice, wherein slice can be thought of as a bag of resources. For example, if you had an experiment on Fabric and you wanted, think of it like if you were using Google Cloud or AWS, you can request virtual machines or bare metal machines, connect them through different networks. You can do similar things on Fabric, but Fabric gives you more lower level control, and and it's funded by NSF, so you have it's free for academic use, unlike Amazon and Google Cloud. And it lets you test your experiment or your topology in a sandbox environment before you're ready to take it to production. So this slide shows how you would do that. You could request a bunch of nodes, connect them uh, on the drag and drop them, draw the topology, how those virtual machines should be connected, and then you just click submit, and your resources would be requested. We did not have way to do this programmatic from the graphical interface earlier, but AI helped us build this tool in a way in like in a short amount of like 2 weeks by only a two people team, and we submitted a paper to PERC, which has been accepted. In the next slide, I'll show you give a bit more about what Loom AI is to give you more context. It has a small video. I'll just play that. I'll now show you the Loom AI tool, which we built for Fabric using Claude's help. This is the tool called Loom AI. The view you see right now is the slices view on Fabric. Slice is a concept on Fabric, which is slice can be thought of as a bag of resources. So for every experiment you run, you would require some virtual machines. They could have accelerators like GPUs, and those virtual machines could be connected on network. So, for example, if I was to run Pegasus on Fabric, I would create a Pegasus cluster. Like in this case, I have requested a bunch of VMs. To be precise, I have 6 virtual machines. Some of them have GPUs associated with them, and some of them are just virtual machines and they don't have GPUs in them. For example, if I wanted to go and open a terminal on one of the virtual machines, I could just right click and open a terminal and then start typing in my commands. For example, if I were to look at the status of Condor, that's what I did. This was not possible even before. Before Loom AI, the only interface to use with Fabric was Jupyter Lab, and we had a very simplistic graphical interface as well on our portal. But oftentimes people would struggle with learning how to SSH into these VMs, transfer files into those VMs. With this tool, we have simplified all those things for our users. For example, if you go to the storage tab, you can drag drop files. You don't have to do SCP or write any command. You can check the resource availability across Fabric on different locations on Fabric, what is available. Oftentimes, the resources available on Fabric some of the resources are very popular. For example, GPUs are not available often if you were looking for them. So we added this calendar view wherein you can check for the availability, so you can request the resources in advance. We also added this map wherein you can see all the locations Fabric is available and what is the current state of that location. For example, all the sites in orange are like almost 76% utilized. Green is like they're relatively free, and red is they're like above 85%. That's what you can do. Not only this, we also retained the old interface, Jupyter Lab. So if all the experiments you created before are still available and you can use them, you can still run them in the native way. In addition to that, we added a bunch of AI assistants into Fabric. One is something called Loom AI. Loom AI is a AI assistant we built. This assistant is trained with Fabric skills. It has information about Fabric, and it can talk to the LLMs we have hosted on Fabric. So all the data, everything you are conversing with it, stays within Fabric and is a secure solution to this. As you can see, I have interacted with it and done experimentation with it. The more powerful thing we did was we also enabled Claude Code in here. So you can run Claude in here and do experimentation. Let me show you how we can do that. Let me go back to this screen, and I am going to open Claude here. This is running as a Docker container, so I have Claude set up in here. I already logged. This is a paid subscription for Claude, so you will use your own subscription. I'm already logged in, so it doesn't ask me, but the first time you log in, it would ask you to prompt. And I'm going to now try and create a slice on Fabric that includes 3 nodes on 3 different sites, and all of them are connected with a network. And the VMs should be running this OS. And imagine I'm just typing in this text to Claude, and Claude also has information about Fabric skills. So it knows how to create slices and everything. And it is going to do that for us. The Slices tab, we can see it will start appearing at the bottom. You can see why a new slice was created, and it is right now in the configuring state. Once the slice is provisioned, it will change to stable okay, and I would be able to see the virtual machines in it. As you can see, I haven't done anything else other than just typing in the prompt. And I also want to highlight that while this is in progress, this entire tool was developed by just 2 people team, Paul Ruth and me. And we had a working prototype in 2 weeks ready. Building this on our own would have taken us a long time. And some of these features we had always wanted, but it was the process of this being up and running was accelerated by using Claude. As you can now see, the slices. So I'm going to pause here, and the intent is not to show you what Loom AI can do, but the intent was to show you that things which would have the ideas which would take a long time developing or building earlier can be fast tracked with AI. And this slide shows like the iterations we took to build this Loom AI tool, and it was just built by 2 people. So we first started with pointed Claude to our OpenAPI spec, and then made sure that it understood it and pointed it to our examples on how those APIs are used, and that helped us build an MCP server. So we thought MCP server could be our solution, wherein people can use their own desktop chatbots and interact with use our MCP server to build their experiments conversationally. That was really good, but it didn't capture all the scenarios or all the complicated experiments people users would want to build. So that's when we decided on building Fabric skills, and these are the skills which you can point to any of the LLM agents. It could be Codex, it could be Claude, it could be your open weight models. And these skills provide information to your LLM about Fabric, about the various API usage, various examples. So when you are asking LLM, it has a concrete information on how it should build an experiment on Fabric. Uh, and then once we had the skills running, we thought, why not build an integrated environment for users where they don't have to worry about um, a specific LLM or a specific tool or installing these skills. They will have an agentic framework where they can just come in. If they want to use the graphical interface, they can use that. Or if they want to use the agentic framework, they would be able to build experiments this way. Let me pivot to a second case study called This is Pegasus AI. Quick idea about what is Pegasus before I dive into how AI was used here. Pegasus is a workflow management system. Think of it like as a project manager for scientific computing. You describe your analysis as a series of steps, like take this data, run this, then run that, and then combine the outputs. And Pegasus figures out where each step should run, in what order, and handles all the bookkeeping. It has been around for 20 plus years and powers things like LIGO's gravitational wave detection. And so it's well tested and well used. Now, coming back to this slide, on the left, you see a scientist with an intent. I want to run this analysis across these data sets. They describe what, not how. And in the middle sits Pegasus, which is doing the hard part. The planner translates the abstract recipe into concrete steps. Dagman tracks which steps depend on which, and HT Condor handles the actual scheduling and dispatches works to machines. And on the right are different resources. So once you build a Pegasus workflow, it is not tied to any specific infrastructure. You can run it locally on your laptop. You can take it to HPC infrastructure, for example, near resources. You can take it to Fabric or any other infrastructure you can think of. So now let's talk about how AI comes into picture. Um, in order for anybody to use Pegasus, there is a bit of a learning curve, even though we have a lot of documentation available. But as a scientist, you want to focus on your science and not on learning how to write Pegasus workflows. So we thought, why not use AI and reduce that learning curve? It is very similar to what we did for Fabric. So let me talk a little bit more about how we did that. Before I talk about what we did for Pegasus, I also want to highlight why Pegasus and AI are specifically a great match. Pegasus gives you robust, scalable, reproducible workflows essentially for free. Like it's explicit. It talks about the inputs, outputs, dependencies are declared, which give LLM unambiguous structure. It's readable, it's Python code based, and easy for LLMs to parse and generate. And it's composable, easy to extend. Those properties are exactly what an LLM needs to be productive in domain. So the challenge is like the scientists can describe their pipelines in a lot of different ways. They can describe their problem in a sentence or a napkin sketch or a published paper's methodology, or it could be an existing workflow they have. Like, for example, Nextflow and SnakeMake are two other workflow management systems. Or they could have just a bunch of Python scripts which they have been running locally on their own laptop. I think most of us start that way. Or they could have a formal specification document describing what are the data sets they want to work on and what kind of workflow they are looking to do. So Pegasus, on the other hand, requires you to learn the Python API, write a workflow generator, build different catalogs, containerize everything, and then run that on htconda. The gap is the real barrier to adoption. So the question we asked, like, what if AI could reduce this gap? Here's the methodology. Like any input on the left becomes a production ready Pegasus workflow on the right. So how we did that, we again, on similar lines to Fabric, we built Pegasus skills by pointing Claude to the various documentation we had, concrete best practice examples, and asked it to build skills. And it generated these bunch of skills. Your job is not done there. You need to also test these skills to make sure they work, iterate over them, validate that they work in all the scenarios, and you can then share with other people. But remember, like just like code, these skills are also living documentation. So you would have to keep updating them as your software evolves or as Pegasus evolves. So using this technique, I being a novice Pegasus user, I was able to build 14 workflows with one total like 190 prompts in 15 days. Um, I would never have imagined me doing that if it were not for AI. So the single biggest practical lesson I learned from all this is spec first. That is, you interact with the AI to build a plan of what you want to build. Argue with it. Don't ask for a single approach. Ask for multiple approaches for whatever you're trying to build. Um, ask and when it prompts you with multiple approaches, it gives you a choice. It gives you several questions to answer. Those are your design choices, and you still retain the domain knowledge. So you hold AI's hand into the right direction. So that is the key thing. What AI is doing for you is writing code, but you are the one reviewing it. You are hand holding it towards the end result. And while you're building the spec, please, I'm reiterating this, focus on test driven development and phased development. You don't want to have a single shot set of code being written. You want to have it built in phases so you can review each phase and then validate each phase until you reach your end goal. Uh, Okay. Just like I showed Loom AI, I've also now been working on building an agentic framework for Pegasus called Pegasus AI, wherein which is built on top of Pegasus skills, so you can build, deploy, and run these Pegasus workflows, and in fact also debug them because uh, as a human or the errors Pegasus reports, there is enough information, there is enough documentation available that you can point the LLM to use that information to help you debug as well if you run into failures. I mean I work even for this case I have been working with another team member, and we have working prototype ready in 2 weeks again for Pegasus AI as well. I will show that in a bit too. Enough about my case studies. I also want to talk about how you can do this for your projects. Um, for example, if you have, you don't have like for Pegasus or for Fabric, what I did was I pointed them to the API documentation, pointed them to the example so I could ground it so that the LLM doesn't hallucinate. So you could do something similar for your project. The approach is transferable. It is not restricted to one project. You point it to your documentation, point it to your API spec, point it to the concrete examples you have, and interact with it to build these skills. Once you have the skills ready, you can use them, test them, and then um, share them with people. And it's an evolving system. So the more you use them, the more accurate they become, and you can keep updating them, just like we would do our code. Okay, this is another example of how I've been talking about how specs are very useful. Before I talk about how I reused a spec, let me talk about like what is a dashboard? Like every NSF or DOE funded project lives or die by its reporting, renewal panels, annual reports, sponsor reviews, and they all want the same thing. Show me your impact. Like what is the impact of the project we funded? How many publications, citations, or downloads, or user counts, top venues, and who is citing whom. And this data, all of us have that data, but it is scattered. It could be in Scopus or Semantic Scholar, OpenAlex, or GitHub, and your own usage logs. Pulling it by hand every quarter is the kind of work that eats a postdoc's week and produces a stale PDF. However, a dashboard collapses that into a rerunnable script. Hit a button and get a fresh report. So that is the carrot. So now the actual, so this is what Paul Ruth for Fabric, who is the PI for Fabric Testbed, he built such a dashboard for Fabric, and he shared that with me, and it was really cool to see. Let me go to the next slide so I can show you how the dashboard look like. If you look here, there are several, it gives you an executive summary at how many users we have, how many institutions, different kind of publications, how many publications. It's really hard to figure out how many people have used Fabric or what publications they have used. So this is all cool, but how can I do that for a different project, right? So what Paul did was amazing, but I wanted to see if I could emulate that using the learnings he had. So based on his dashboard, he used Claude to build a spec document and an interview questions. Both of them are the markdowns. He shared those with me, and I used those that spec file as well as the interview questions markdown and pointed it to the projects I am working on, which was like Pegasus. So I asked these two, if you look, these two are very different projects. Fabric offers resources, so you are actually providing resources to the researchers. But Pegasus is you're building workflows. They're completely different. They are not identical at all. But but because of the interview questions it takes, I was able to interact with the AI assistant and answer them questions like what is the main goal of this project, who are the key contributors on this project, or who are the super users of the project, whose publications it should target, and by answering all those interview questions and using a spec file, I was able to interact with AI and build a similar dashboard that made more sense for Pegasus. I mean, I also had access to some of the Pegasus metrics provided by Pegasus team. So it created a work dashboard like you see on the screen, showing how many workflows were executed, where were they executed, what kind of applications have they been running, or how many applications have they been running. I'm showing very small snapshot of what all the entire dashboard looked like. But this was just to give you an idea that you could do something similar if you had the spec file as well, and you don't have to start from scratch. So yeah, so in this case, for example, um, how many how many papers cited Pegasus, how many GitHub stars were received by different GitHub repos Pegasus has. Okay, this is another example. Like I also use the similar spec file and interview questions with another project I'm working on for Sperm, which is also a research project. It doesn't involve anything related to the infrastructure, but because of my interaction based on the spec file, God was able to build me a dashboard here. In this case, it talks about how many publications we have had, what kind of venues these publications were published on, and it even was able to plot graphs of for each member of the team and how many citations. So the key takeaway is that the spec file is a reproducible artifact. You don't have, like, it can work against different projects if the idea is being captured um, well while you're interacting with AI assistants. So like earlier, code used to be a reproducible artifact, but now even these spec documents are reproducible artifacts. If you build something really cool, you can share your spec file with someone else and they would be able to build uh, a similar app, but relevant to their work. Okay, coming back to more how you would use this. Like, for example, I was supposed to give this webinar, and I was a little bit skeptical on how I would build this slide deck because I had so much to talk about. So I thought, like, what if I can provide talking points or the bullet points of what I want to cover in this webinar and send it to Claude and see if it can build me at least a starting point. And that's what I did. Like I had a list of talking points I wanted to cover in the slide deck, give it to Claude, and it spun up a bunch of placeholder slides. Some of them even put some of the content as well because I pointed it to the information I had in different directories. Obviously, it wasn't this perfect. I had to re-review, modify the content, but it was a great starting point that I didn't have to start from scratch. Focus on the formatting and the color coding or the logos or the grand numbers on the slides. That was pretty useful. So I thought I'll share that with you so you could also try this. So this is an example. For example, uh, so what you do is like it's an extension for Microsoft PowerPoint. You just download it, and then once it's enabled, you see Claude within the PowerPoint, and you can interact with it, and it'll let you build slides. There's another thing called Claude Design, which also lets you build slide decks. I know I'm going to skip through these slides, but the idea was that you can build slides, dashboards. There are different ways. For example, this is another tool Claude offers, which is Claude Design, which I have been using to build slides if I wanted to start from scratch. Or in fact, I think I have found Codex desktop app more useful for building slides. In this case, I was presenting something. I already had an example of a slide deck and I pointed it to it and I said, look in this directory. Already have documentation there and this is the base slide I want to use. Can you update the slide for me? And it did create the slide. So it can help you, like it can give you a lot of time, save you a lot of time. Okay, another thing I've been trying recently is uh, oftentimes we build things like, for example, we built Loom AI. I have also built Pegasus AI. These are new tools, but you want people to be able to use those tools, and you need tutorial videos. You saw the tutorial video I recorded, but what I was thinking, like, couldn't AI do that for me? And that's what I did. I've been using AI from like this is very recent. I tried this like last week, and I was able to build tutorial videos with it. I was going to show that, but I think in the interest of time, I'm going to skip that. Um, so what is AI genuinely great at? Um, it's really good at generating boilerplate and glue code, large scale refactors and API migrations. And if you are onboarding to an unfamiliar code or you're trying to test something on beyond code, it can turn a paper into a slide deck in an hour, draft grant and progress reports. Of course, you have to review all the content it generates, but it takes away a lot of tedious work. It does a lot of tedious work for you, which would have taken a lot of consumed a lot of your time. Where it, however, where it falls down is also a key point. Domain-specific protocols, things which are not underrepresented on the public web, or subtle distributed system bugs, for example, race conditions, partial failures, or clock skew, and you can't expect it to architect stuff for you. The design and the domain knowledge are still with you. The key point is that you control all that. It can do the tedious work of coding, um, but you understand the bigger picture, yeah, and you still control the narrative. So the patterns that have worked for me are like small scoped tasks, beat the big vague ones. Grounding it with examples helps a lot. Prevents it from hallucinating. Doing the spec first approach ensures that you are using tokens efficiently, so you don't eat up a um, lot of your usage for the week if you're using these paid models. Another thing to focus on is like when you're using AI assistant to build things, writing code is super cheap. It can generate huge amounts of code for you, but now the bottleneck is that you as a human have to review what it is generating. So that's why I was emphasizing on test-driven development, because it's humanly impossible for us to review every single line of code you had AI assistant generate for you. That's like too much. Um, but if you, from starting, if you build your system in such a way that you have enough tests, every time you ask AI to build something, you run those tests, and then it's easy for you to verify that it's doing the right thing. So I think the key thing from all the takeaway from all this is that having the domain knowledge, the bigger picture, and being able to identify what it generated or what the results it is showing when running this application, are they correct or not? That still lies with us as humans. It cannot be all AI driven completely. The quick reality check I also wanted to talk about was definitely cost and security. If you are using these paid LLMs, it does it adds up. So we should definitely budget for it when you are planning projects. But it does gives you an edge if you're using them. And with respect to security, if you are working on a project which has sensitive information, so you don't want to use these commercial LLMs like Claude or Codex, you want to host your own self-hosted LLMs using open weight models. So all the data or all your interactions stay within your facility. Um, that way you're doing everything in a secure fashion. You don't want to do that. In fact, if you're using paid LLMs, you don't want you want to ensure that you have set enough guardrails that it's only working within a specific directory. You don't ever want to give it access to your personal information, or if you have your credit card information saved somewhere on that same system. So that is really important. And definitely check with your institute's AI policy before using any of these commercial LLMs for your work. Um, Before I close, like I want to everyone leaving with one concrete next step. Like if you're a developer, install these one of these tools and hand it one boring task you're doing end to end. Don't supervise it, just see what it does. It may come back and surprise you, or it may come back and do completely wrong things. But you'll figure out how to use it. And if you are a PI, try drafting your next progress report or a grant section with AI. It may be terrible to begin with, but you will have a starting point. You can always interact with it to improve, or you can edit the version it generated for you. And if you're a project manager, pick one of the recurring artifact and automate it. And if you're a student, try building your website. If you have been postponing it for a while, it can spin up your website in a matter of minutes. So the point is, try it, use it. Only then you'll know how useful or not unuseful it is for you. These are a few other things I wanted to just bring them up. I am not going to go into detail about all of these, but if your institution is offering you credits for different LLMs, try using a light LLM that allows you to control the keys for them. And then if multiple people are working on different projects together, and or even for you, if you're using different tools, for example, you're working on Codex and then you just want to switch to Claude, but you're still working on the same project, you can use things like Brain, wherein your thoughts could be stored and you don't lose context when you're switching tools. And I already talked about how you can build slides or tutorials and try building your own website. I think I'll end here. Thank you so much.
All right, thank you, Komal, for that great talk. We do have a lot of questions on the chat and also questions that we got during the registration process. So we'll try to get to them, get to as many of them now. But if we can't, we'll send out a thank you email with our email addresses and contact information, and you can reach out to us. So I tried to synthesize some of the questions. I think there are a couple of questions, both during the registration and during chat about the mode of usage of cloud. Was it run locally? Did you use cloud plugins? Did you use managed cloud? So can you tell briefly about it?
Okay. I've been using Claude as both as the desktop app as well as the command line interface. I have been using Claude more to build things rather than you deploying Claude agents in production. So if that is because I don't think I trust it enough right now to do things for on my behalf in production, and that's why our focus has been building tools, building code from it, so we can verify it works well. I think I started with I started last November. I don't remember the model I was working on, but now I've been using Opus um, with the model setting as high. Uh, in addition to Claude, I've also been using Codex. GPT 5. Older versions of GPT were not that great, but GPT 5.5 with high effort setting works. It has been doing decent stuff. Sometimes it wanders off, so you have to tell Claude, can you nudge it in the right direction?
Great. I think the next question is about how do we create these spec files and skills? What are the best practices for using that?
For skills, I would reiterate, point it to your documentation. If you have an API spec, for example, in our case, we had Swagger API spec, we pointed it to that. And not only to the documentation, also if you have concrete examples. For example, in case of Fabric, we had a huge repository of various examples which we were already sharing for people. So I pointed it to that too. So you grounding it with concrete examples makes sure that the skills you generate are very grounded and real. It doesn't hallucinate as much. And once you have generated the first version of skills, try using them. Like like you don't have to run them yourself. In fact, ask the AI assistant to use that skill to build a bunch of examples you pointed it to and see if it does the right thing. So it's a bit of iterative process, but it doesn't take long with AI's help.
Uh, cool. So there's another question is, I'm interested in analyzing and responding to data in a secure agentic model. So can you touched on the security a little bit toward your end, but can you um, say a little bit more about safe use of AI, safe use of agentic systems? Yeah.
Okay. Uh, Depending upon how sensitive your data set is, I wouldn't like if you're worried about being sending that information out to these commercial LLMs, I wouldn't recommend using them. If you can host, I've been using VLLM and Hugging Face models to host LLMs on NVIDIA DGX Sparks, or you can even run them locally on your own laptop, or if you have a powerful virtual machine, you can run them there too. But these NVIDIA DGX Sparks are good for inference. They are not very expensive devices, so we bought few of them for Fabric, and we hosted some of the models there. And if you plug in the similar set of skills against those models, it does pretty decent job. In that way, your entire data set is secure. No information is leaving your own sandbox.
Sure. So can you share a couple of observations that you made um, that that made you see the potential of Gen AI in certain contexts, right? Creating the tutorial videos or creating the slides. Can you provide your input on that?
Okay. I think it is super useful, as in you have to take this with a grain of salt. It won't be as good as you, but it's getting better day by the day. Whatever I could do 2 weeks back, like you are become things are becoming stale in a matter of weeks. So you have to be on top of it. But It definitely helps you in the sense that your starting point is not a blank slide deck or a blank video wherein you're recording everything. Um, it's been only 2 days that I started doing these video things. Like I just did this yesterday. I had a vague idea of what I wanted. I interacted with it. In the beginning, it wasn't doing the right thing. It didn't know how to do a voice layover over um, the screenshots it was capturing. But I could nudge it in the right direction, point it to tools like Kokoros, which does this voiceovers as well. And I'm not happy with the video it generated so far, but it's a very good starting point. And it was done like within a couple of hours. And
Hmm.
imagine if once you have built a project wherein you have built all the skills and taught AI to build your tutorials, every time you have a new feature, you just have to set one prompt and the video would be ready for you instead of you doing it manually every time. So it's pretty game changing.
Great. A couple of times you mentioned interview question, like both for Pegasus AI and Fabric tools that you created, right? What do you mean by interview question in this context? Are you interviewing users or is this an AI concept?
Okay, it's like it's similar to a spec file because the dash, like if you're building something which involves in questioning the user who's building things, uh, the AI assistant would generate a markdown file which has a bunch of questions in it, and that's what I was referring to as interview questions. Um, you can call that markdown file anything else as well, but it's a way for your AI assistant to ask you or prompt you for information it needs before it builds stuff for you. So spec has the design, and if there are open design questions, I save them in interview questions markdown file.
Sure. Just we'll get to the last question that we can get to. It's a two-part question. Do you have an A10 integration of Fabric or in any of your other tools? And second part, what are your thoughts on running local models on-site versus wrappers and or access to frontier models?
I did. I started with N8 when I was starting to learn how to use AI for this, but soon realized that N8 wasn't powerful enough, and I was able to get more value out of using these frontier AI assistants. Or even for that matter, open weight models like Kimi, they have given me like better results as well.
And your thoughts on running local models on-site versus wrappers and or access to frontier models?
Local models are pretty good. If you have enough skills built into them, they have to be more. The kind of information you pass into these frontier models can be less. You don't have to describe, you don't have to be very descriptive about what you are asking. But if you're using these low open weight models, you have to be a little bit more descriptive, but you can get enough out of them as well.
All right. Thank you, Komal. Well, as I said, please reach out to us for any additional questions that we could not get to during this session. I'll hand the baton to Amanda.
Thank you so much, Kamal, for your amazing presentation today. I'm just really excited by the engagement we've seen. Anirban, thank you as well for providing the great introduction and facilitating the Q&A. I am pretty certain that you're going to have some follow-up with some folks who have participated today, and we welcome that, just so you all know. We do welcome collaborations and we're building those. And you know, if you have any questions, we've dropped Kamal's email address and Anirban's in the chat. We will be including those in our wrap-up materials. We'll be sending a recording of this webinar later this week, and you'll be able to reach out to them with specific questions you might have and other collaborative opportunities as well. But I really hope you've enjoyed today. Do take a minute to scan this QR code and sign up for our newsletter because we would love to tell you about additional programming we have coming up this fall. It'd be great to learn alongside you again in a couple of months. We are taking the month of July off. So we are a minute over. Sincere apologies, but thank you, Kamal. Thank you, Anirban. Such a pleasure to work at RENCI with you. And folks, I do hope you enjoy your summer. Take care, everyone. Bye-bye.
Thank
Thank
you.
you.